Hallicrafters Skyrider Jr. S41G, 1945, 1946. This is the documentation of the experience of a hobby project, made with the hope that it could be helpful to others. However, these videos are not intended as tutorials. They only show the development of a personal practice, which may or may not be a good one. Therefore, if you are following along, you are doing so at your own risk. The Hallicrafters Skyrider Jr. S41 was a small receiver made by Hallicrafters, initially with a different brand name, Ecophone. The precursors were Ecophone EC1, EC1A and EC1B, followed by the Hallicrafters S41G and S41W. Basically, the models Ecophone EC1B and Hallicrafters S41G and W are electrically identical. At the end of 1946, the model S41 was not advertised anymore in favor of the Hallicrafters S38, which took its place. Here is the comparison between the adverts published by the same distributor appearing in the magazine QST, March 1946 on the left, July 1946 on the right. In July 1946, there was already the Hallicrafters S38, and the next time the model S41 disappeared from his adverts. For the purpose of being cheaper, all these models did not contain a power transformer and therefore were hot chassis radios, which means that their chassis is connected to one of the power lines coming from the mains. This would not be a big deal if the cabinet were not metallic, isolated from the chassis only by 4 grommets and by a very narrow clearance around 1 millimeter. Therefore, nowadays, these should be considered extremely dangerous radios unless something is done to prevent the risk of electrocution. Another aspect that shows the intention of cutting costs in this radio is the movable core inside the oscillator coil that has the function of a fine-tune adjustment or band spread in place of the more common specialized variable capacitor. As a reference, these last pictures appear here because they show an untouched circuit under the chassis, which may be useful for making a comparison with a partly serviced unit, like it is the one of this restoration. The unit of this restoration arrived in bad shape. There were brown stains all over the cabinet, especially on the front, as well as white paint splashes. The screws responsible for holding the chassis on the metal cabinet were missing. The back panel and the loudspeaker were missing. Before extracting the tubes from their sockets, it is better to remove the top panel. Unfortunately, all the tubes are stuck in their sockets. Some Vaseline oil is poured in the sockets, but at the moment that is not enough for releasing the tubes. The bottom panel is also removed, and more Vaseline oil is inserted in the tube sockets from below. It is still very difficult, but with patience the tubes can be removed. Before proceeding further, it is advisable to save a thorough scan of the contents under the chassis. There are at least 3 different sources for the schematic diagram of this receiver model. The first one is the original service data, partly reproduced also in the Ryder manuals. Then there is the service data for the Ecophone 1B, electrically identical, which is more accurate in the representation of the dial spread and in the alignment procedure. And finally, there is the SAMS PhotoFact folder 1946, which also represents all the expected factory voltages. Considering that the original documents available online have been reproduced with insufficient resolution, and observing that there are little differences in the values of a couple of components contained in the unit of this restoration, the schematic diagram has been rewritten, and is available with better details in the written documentation that comes along with these videos. This is a very dangerous radio receiver because the chassis is connected to the mains regardless of the fact that the power switch is turned on or off, and because it has a metal cabinet, poorly insulated from the chassis and coupled with a capacitor of an excessive value. The rectifier tube is the Type 35Z5, which allows to connect a dial light across a section of its filament. Unfortunately, that section of the filament between the pins 2 and 3 may also be traversed by some of the current that flows to the B+ output, and there are a lot of used tubes of this type around with this section of the filament open. Anyhow, in the circuit of this radio, if the tube is still fully operational, it is absolutely necessary to have installed a working dial light, which must be precisely the Type 47. If the rectifier tube had lost that portion of the filament, some adaptation should be studied, but luckily this is not the case in this restoration project, at least for now. The B+ current coming out from the rectifier tube is divided into 3 different lines for different parts of the circuit needing different voltages. In the oscillator coil of the RF section, there is a movable core with the function of fine-tuning. It is important to observe how the antenna is connected to the antenna coil. Unfortunately, there is no decoupling capacitor, which exposes the coil to external currents, especially if the antenna ground is connected. One of the antenna windings does not look good. This cooked winding became so hot that it sprayed its insulation, leaving even a large stain under the chassis. Very likely this is one of the 2 primary windings of the antenna coil, and it is possible to test the continuity of them connecting the ohm meter to the antenna input. And yes, the open winding is the one used for band number 1, medium wave. The upper side of the chassis is cleaned with some oven degreaser first. Then a few signs of corrosion are treated using a gel rust remover. The residues of these products are later cleaned using alcohol. Before taking care of the open winding in the antenna coil, the paper and electrolytic capacitors are replaced with modern components. A few resistors that appear to be out of tolerance are also replaced. In particular, the antenna input is now fully decoupled using safety capacitors. The capacitors C24 and C25 are also replaced with safety components, but the value of C24 is also significantly reduced. Since C24 is now much smaller, it is connected to the volume potentiometer shield because that is attached to the metal cabinet. Finally, the radio is tested using an isolation transformer and dim bulb tester. It receives even in the first band, which has the antenna primary winding open. In order to try to repair the open winding in the antenna coil, it is necessary to determine where it is connected. The whole coil is held to the chassis by a single screw, which is removed, allowing to lift the coil without disconnecting it from the band selector switch. It is possible to determine that the open winding was connected to these two eyelets. The plan is to insert a 1 mH inductor inside the body of the coil, right under the open winding. But that could be done even if the coil is in its proper position under the chassis. Initially, the inductor is connected only on one side because it is necessary to verify if the orientation is constructive or destructive in comparison with the parasitic coupling that already allows some reception. The test is done using insulated tweezers. Current orientation works well, and the floating terminal of the inductor can be soldered to its eyelet. The IF transformers are observed, considering the opportunity of opening the cans for inspecting them inside. In this unit, the first IF can was stuffed with some paper, visible from under the chassis. It is unknown why, but it is possible that that was done by the factory for some reason, considering that another restorer published pictures showing the same staffing, with the difference that in their case both IF transformers were stuffed. The option of inspecting the IF transformers is put aside, choosing to verify the existing alignment instead. The oscilloscope probe is connected to the volume potentiometer, where in this receiver it is possible to read the AGC voltage. The signal generator is set for providing a sweeping signal around the expected value for the IF chain, connecting it to the antenna input while the band selector is in the first position. Here the signal is sweeping between 443 and 453 kHz, observing a peak in the AGC line in the middle at about 448 kHz. Therefore, a preliminary alignment is performed, setting the signal generator for 455 kHz non-modulated and adjusting the trimmers on top of the IF cans for reading on the oscilloscope screen the most negative voltage. The amplitude of the signal injected to the antenna is kept as low as possible, as long as the effect can be perceived on the AGC line. It was not verified if the trimmer screws are isolated or not. Anyway, the alignment is done using an insulated tool. When the alignment is completed, the signal generator is set again for sweeping, but this time between 450 and 460 kHz for verifying the shape of the negative bell curve on the oscilloscope screen. In order to separate the chassis from the metal cabinet, it is necessary to disconnect the 4 slide switches, which are operated from the front side. They are attached to the cabinet using rivets, and it is not advisable to drill them out. The original slide switches have only the posts that are strictly necessary for the function that each one of them has. Therefore, it is easier to map them for keeping memory of the connections. For distinguishing the wires, some small rings of heat shrink pipe are used for marking the corresponding switch and post to which they were connected. The color identifies the switch, the number of rings specifies the post. When all the slide switches are electrically disconnected, it is time to remove the knobs, and then it is possible to release the volume potentiometer and the band switch selector, leaving them connected to the circuit. Finally, the chassis can be extracted. In the original design of this radio, the cabinet is isolated from the chassis only by 4 grommets, which are not in good condition anymore and are replaced with new ones. The small chassis is not heavy, while it has no power transformer. Therefore, 2 pieces of cardboard are judged sufficient for keeping the chassis slightly elevated from the bench surface while working on it. The dial scale is removed, starting from extracting the 2 indicators. A picture of the dial scale is kept for reference. The size of the surface is 146 by 108 millimeters. The dial cord for the band spread is broken, and a replacement needs to be installed. The controlling shaft is too thin and the new cord slips on it. Therefore, something must be done to obtain a better friction. A piece of Heath shrink pipe is used for the purpose. Now it works, and it is possible to seal the knots with superglue. Some Vaseline grease is added where appropriate. This is a very dangerous radio, and it is appropriate to do something to improve its safety. At this point of the restoration, some Kapton tape is attached on the side of the chassis where it is too close to the metal cabinet. The excesses of tape on the side are not nice aesthetically, but they are left for making sure that all the surface on the two sides of the chassis remains insulated. The grommets are installed back where they were, on top of the tape. The case of this unit is in very bad shape, considering that it is important to preserve the writings as well as the original colors. There are brown stains, white paint splashes, and rust spots. The transparent dial plastic is removed and cleaned using slightly abrasive products, because together with the paint dots, it also has deep scratches. Some homemade gel rust remover is applied on the visible rust spots over the metal case. An oven degreaser is used with the help of a toothbrush for cleaning the stains and the paint splashes. After having cleaned the case from the residues of these products, the switches are masked. But then more rust is noticed on the upper part of the case. Therefore, the case is partly submerged in some liquid homemade rust remover based on citric acid and baking soda for a few hours. Later, the masking tape is removed and the case is washed with water from all residues and dried with a hair dryer. For improving the isolation between the case and the chassis, some extra insulation is added on the side of the cabinet. In this case, some thin corrugated cardboard is used, but in retrospect, a thinner non-corrugated cardboard would have been more effective. In the end, some clear anti-rust paint is sprayed on the case inside and outside, but this is done off camera. In the original configuration of this radio model, the chassis is connected to the mains, and there is a 50% chance to have it linked to the hot line. While restoring units like this one, it is necessary to make sure that the chassis will always be connected to the neutral line, moving the power switch to the hot line and using a polarized plug. However, this is not enough because one should also make sure that all the external electrical power wiring is correct, especially the power extensions, which are usually the sore point in terms of correct polarization. Moreover, this particular unit is going to need a step-down transformer in an electrical environment where the power outlets are not polarized, and therefore it is not possible to predict which side is neutral and which is hot. While using an autotransformer, if the input power is reversed, both output lines will be elevated. For this reason, it is important to include in the radio some kind of indicator that could tell if the input power is not polarized correctly. But for this purpose, it is necessary to use a reliable external ground as a reference. This circuit was already used in a previous project, and it relies on an active buzzer type SFM20B, which works well in all circumstances. For reference, also the type YMD 12095 was experimented this time, but the result was not satisfactory in this particular circuit. The input power is about to be modified for safety reasons and for controlling the input current. The power switch will be moved to the hot line, leaving the chassis always connected to what is expected to be the neutral line. The metal cabinet will be connected to the external ground. 2 fuses and 2 noise filtering capacitors will be added. An array of halogen light bulbs will be inserted for controlling current surges and for dropping some voltage. The exact specifications for this set of light bulbs will be determined based on the tests that will be done later. The buzzer circuit described in the previous section will be added for signaling an elevated voltage on the chassis. All this is meant to be installed on a small plastic box to be placed in a narrow space over the chassis close to the rectifier tube. At this point, the plastic box has been already prepared with the necessary holes, and the sockets for the halogen light bulbs are prepared, inserted and connected in parallel. Two fuse holders are installed on the box, also using super glue for making sure that they would not turn accidentally while inserting or extracting a fuse. There is a very thin clearance between the fuse holders and the wires of the halogen light bulbs. Therefore, later it will be insulated with plastic sheets. It is now time to connect the power cord to the fuse holders. Therefore, the new 3-prong power cord is inserted in the chassis through a cable gland that fits perfectly with the original hole. After having connected the power lines to the fuses, 2 noise-limiting safety capacitors are installed. All the necessary connections inside the box are made, including the extensions that will be directed under the chassis. The promised insulation sheets are prepared and inserted between the fuse holders and the bottom of the box. The buzzer circuit is connected between neutral and ground line. The lid of the box requires a little adaptation. The active buzzer is glued outside the box initially on the lid. The box is held on the chassis with a single self-tapping screw through an unused hole. The power cord is carefully aligned to the edge of the chassis and then secured using zip ties on a brass washer that was previously soldered on the chassis for the purpose. The box is opened again so that the screw that has been inserted for holding it to the chassis can be insulated inside. Finally, the position of the active buzzer is changed for reducing the exposure to the heat generated by the rectifier tube. Before putting back the plate containing the dial scale on the chassis, it seems a good idea to insulate the bottom part that is bent forward, because that will be very close to the metal case, about 1 millimeter only. Once the dial scale is in its place, it is possible to position also the two indicators, paying attention to their correct orientation. They must be able to travel their entire scale also without scratching the dial. The metal case has been sprayed with a clear anti-rust paint, which now is dry, and it is prepared for hosting the chassis. Inserting the chassis in the case is a bit of a struggle because of the presence of the thin corrugated cardboard that has been added on the side of the case. The unit arrived without screws on the side of the case, and only two of the original special metal inserts that would have fitted inside the insulation grommets. Therefore, instead of using metal screws, which could get in contact with the circuit inside the chassis, nylon screws, nuts, and washers are used together with extra small grommets for filling the holes inside the larger ones. Everything is reconnected in the way it was before. The power source comes now from the black plastic box previously installed on the chassis. The neutral line is now always connected to the chassis, and there is also the external ground that must be connected to the metal cabinet. This unit came without the speaker. A possible substitute is found and tested, measuring the impedance of the output transformer when connected to it. The result seems perfectly acceptable for the driver tube type 35L6. Therefore, the substitute speaker is approved, and it is prepared with small grommets. A piece of fabric is also prepared for placing it between the speaker and the grill in order to reduce the dust exposure to the speaker cone. The top panel is installed only temporarily, because it will be necessary later to access again to the upper part of the chassis. The original design of this receiver included a capacitor of 250 nanofarads connected between the chassis and the metal case. The reason for this is to reduce the hum introduced by the floating ground of the metal case, which is in contact with the shield of the volume potentiometer. However, considering that the chassis is connected to the mains, this relatively high capacitance value is unsafe. Therefore, up to this point, that has been replaced with just a 10 nanofarads safety capacitor, connected directly to the shield of the potentiometer. However, so far the result is not satisfactory, and a significant AC voltage can be measured between chassis and metal case. Depending on the impedance of the meter, the result varies, but it is still an important differential. Incidentally, all these tests are done powering the radio through an isolation transformer and dim bulb tester. Therefore, during these tests, it is possible to connect the chassis to ground. Shorting the chassis to the metal cabinet, the hum would become quiet, but this solution is not acceptable for obvious safety reasons. An attempt is made to increase the capacitance between chassis and metal case without exceeding 30 nanofarads in total for safety concerns. It helps, but that is not enough. Considering that this hum is introduced mainly by the shield of the volume potentiometer, an attempt is made to isolate it using some thin heat shrink pipe and nylon washers. This trick helps, and here is what has been done, translated into the schematic diagram. Later, also the value of capacitor C27 is increased. John Foring, in his page dedicated to the Ecophony C1, among other things, describes his restoration experience and, in particular, suggests a modification to the BFO. The issues described by John Foring regarding the BFO arrangement of the C1 are the same that affect the model of this restoration, and the same modification is experimented. Basically, it involves collecting the signal from the plate of the tube instead of the grid, and to inject the signal to the control grid of the IF preamplifier tube, 12SK7, being careful to not overload the IF chain. That turned out to be easier said than done, because every time that something is coupled to the control grid of the IF preamplifier tube, even if very loosely, the first IF can should be realigned to understand what would be the actual input signal. After various attempts, the configuration visible on this schematic diagram is applied so that the intensity of the BFO signal could be adjusted anytime without moving wires and therefore without interfering with the alignment of the first IF transformer. The trimmer resistor is installed on a small piece of prototyping board, which is placed behind a hole on the chassis that was meant for hosting a slide switch, but was never used and is conveniently located close to the BFO oscillator. The IF alignment is repeated. This time, the signal is modulated, injected as usual at the antenna input, while band number 1 is selected and the variable capacitor is fully meshed. The signal is read by an analog oscilloscope, loosely connected to the output of the last IF transformer on the wire that goes to the detection diodes. By loosely connected, it is intended that the oscilloscope probe is hooked to the insulation of that wire. The IF transformers are adjusted, looking for the widest signal read on the oscilloscope screen. Once that is done, the same signal, but non-modulated, is used for the alignment of the BFO, activating the oscillator and seeking the zero beat point, which corresponds to the exact match between the IF and the BFO frequencies. The alignment of the dial does not require the oscilloscope anymore because it can be done by ears. This time, the modulated signal is applied to the antenna input using a dummy antenna, and every time the signal generator frequency must be the same as what the radio is supposed to receive, choosing the band and setting the dial consequently. Initially, the frequency generator and the radio are set for 600 kHz, and the trimmer capacitor C21A is adjusted for a peak. Then, the frequency is moved to 1800 kHz, and the trimmer C22A is adjusted for a peak. But the process for C21A and C22A is repeated until there is no more adjustment to be done, and at that point it is possible to return to 1800 kHz and adjust C4A for peaking also the antenna front end. The same process is done for band number 2 and number 3, with the exception that band number 3 does not have a C21C for setting the lower side of the band. This particular unit will be used in Europe, where there are important stations in the medium wave band that are located below 550 kHz, which is supposed to be the lowest limit in the first band of this receiver. Therefore, before doing the alignment of the dial, the tuning indicator was set in the position that is visible in this picture, with the variable capacitor fully meshed, so that at the end of the alignment also the frequency of 530 kHz could be reached. The rectifier tube found in this unit is like new, but it behaves in a strange way. First of all, observing the official data sheet of this tube type, we know that the filament is connected between pin 2 and pin 7, and that there is a tap connected to pin 3. The filament current is 150 milliamps. The voltage across the entire filament is 35 volts. The voltage across pin 2 and pin 3 is 7.5 volts, and consequently the voltage between pin 3 and pin 7 is 27.5 volts. But this is not true for the tube found in the unit of this restoration. Testing for resistance, between pin 2 and pin 7 there are about 33 ohms. But between pin 3 and pin 7 there is a higher resistance of about 42 ohms. Basically, the pins 2 and 3 are inverted. Also powering the filament using a bench power supply, controlling the current to 160 milliamps, which is already beyond the specifications. Between pin 2 and pin 7 one gets only about 27.5 volts. This problem was discovered by checking the voltages, which are those represented in this portion of the schematic diagram. It is clearly visible that between the pins 2 and 3 there is a differential of only 1 volt. Knowing now that that depends on an inversion of the internal connections of the rectifier tube, this is justified by the fact that that portion of the filament is not powered and remains cold, creating almost a short circuit. It was not mentioned before, but of course the light bulb 47 was extremely dim. The real reason for concern was the low differential between the pins 2 and 7, only 26 volts. The consequence was that all the chain of filaments was affected. In particular, the final amplifier tube compensated with a differential of 37 volts instead of the expected 35. Under the circumstances, the final amplifier tube was drawing more current between anode and cathode, which increased the cathode voltage to 9.9 volts instead of the expected 5.8 volts, therefore making the control grid more negative compared to the cathode. The result was that with lower power voltages, for example 110 volts instead of 115, the output volume was higher. Because the replacement tubes 35Z5 that are available for this restoration have all the section of the filament between the pins 2 and 3 open, and because there was no intention of inverting the wiring under the tube socket, the solution chosen for solving the problem was radical. The original tube with the pins 2 and 3 inverted was put aside. Theoretically, sometime in the future the base could be separated from the glass envelope and rewired correctly. Another 35Z5 with the segment between the pins 2 and 3 open was put in circuit, shorting the pins 2 and 3 and connecting the anode of the tube only through the dial light, which would become a fuse for the B+, providing no useful light to the dial. This clip shows a test made for verifying that the dial light could stand the new configuration. The assortment of halogen light bulbs used for controlling the input power current was changed in order to reduce the input voltage that reaches the original circuit. This picture shows various voltages depending on the input power. The values in color red are the factory expected voltages. Those written in purple show the measured values, with 122 or 113 volts AC input. Later, another 35Z5 tube with a better emission will be installed, obtaining higher B+ voltage and current values compared to what is visible here. The choice of using halogen light bulbs for dropping some voltage and controlling the surge currents is a very personal thing which other restorers dislike. In this unit, due to space constraints, these light bulbs are facing a corner where it is particularly difficult to reach them. The electrical restoration is finished, and here is a last view under the chassis. Here are the capacitors together with 2 resistors that have been replaced. For memory or reproduction of the writings on these components has also been made. This is the final schematic diagram containing all the amendments applied to the unit of this restoration. As already mentioned, the B+ voltage and current values that appear annotated in purple were measured before changing the rectifier tube, with one having a better emission. The buzzer alarm is tested. When the power plug is incorrectly inserted, it emits an audible sound. Most of the units of this series of models have lost their original back panels, which however is mandatory for very basic safety concerns. A drawing is made for obtaining a 2 mm thick acrylic glass with all the necessary holes, which could fit well in the item of this restoration. As usual, a better detailed representation of this drawing is available in the written documentation that comes along with these videos. This particular design takes into account the relatively large cable gland used to hold the power cable securely to the chassis, which has the disadvantage of letting an important area of the metal uncovered and needing some other form of insulation. The panel had to be ordered from professionals who can use all the appropriate tools for cutting acrylic glass perfectly. Before inserting the new back panel, it is necessary to remove the screws of the antenna posts and to insert the insulation patch for the area that otherwise would remain unprotected. Every hole was planned correctly, with the exception of this one for the BFO alignment that is slightly off-center. However, in the drawing already shown, as well as in the included written documentation, the mistake was corrected.
Saudita apoi va ajunge în Qatar și în Emiratele Arabe Unite. Scopul turneului este consolidarea parteneriatelor din Europa și America de Nord. Cancelarul federal Friedrich Merz își îndreaptă acum atenția spre consolidarea relațiilor.
This model has a fine-tuning mechanism based on a moving core inside the oscillator coil, which unfortunately does not work smoothly as it should. Basically, the oscillator frequency fluctuates irregularly, and it becomes useless when trying to tune to an SSB communication. Therefore, its function remains mainly ornamental for aesthetical symmetry. Here is how it looks like tuning to an SSB communication using only the main tuning knob.
Delta Loop 40 meter band, 40 and 21. Claudio, mai back to you. Scusa Claudio, buonanotte, 661 Comole, BS23, arrivederci from Delta Lima 1, Delta Golf Sierra, bye.
The restoration is finished, and this is the last reception test, done in the evening, using only an indoor loop antenna for all bands. It starts from band number 1, and it ends with band number 3. The radio is powered using an external isolation transformer.
Tiene el título, sí que tiene finales. El título el Deportivo Alavés, Real Sociedad, que cuentan Roberto.
Sicuramente lui, e questo viene a fare un nome per quello che si... Bueno, pues era una real verdad.
Sin barreras, sin sacar el discípulo Pérez, pero que sale muy buena. Vamos, que está bien. Libres, casi 3.
Come si dicono riabitanti stessi e difficoltà. La differenza
Так, подошел босиком, наверное, с койки и сразу к микрофону. Ну, пару CSP маленько. 9 CSP зовут Сергеем. На приеме.
Încă era în Thailand. Am auzit de hărnicia și de... meditava och resa mig متوجه بشه این اشتاق بیرحمانه بدون جواب نیست.
گفتگوی بود با شیرین عبادی حقوقدان و
Причем даже в концлагерях появлялись
خودی هستند.
وزارت دفاع و ما شرکت
Antwortende Adressen. oder criper@kuku.com.
Sayın dinleyiciler, Türkçe yayınımız sona erdi. Her gün 다른 저희가 양이가係一幅畫，係一幅水墨畫。Radio sur l'application Bonjour